Hello class, in our last session we have seen the colligative properties, that is relative lowering of vapor pressure. We have seen the formula that we have derived for the calculation of molecular mass of a solute, and after that we have seen very important past ISC numericals based on the topic that we discussed, relative lowering of vapor pressure, that are very important. Now today we are going to discuss about the second colligative properties, that is elevation in boiling point. Now let us try to understand what does this term means, elevation in boiling point. So before that we try to understand and define the boiling point. Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. So boiling point is that temperature at which the vapor pressure becomes equal to the atmospheric pressure, that we call it the boiling point. And once again, as we know that the vapor pressure of solution is always less than that of solute. This we have seen in case of Raoult's law of lowering of vapor pressure. So as we know that the vapor pressure of solution is always less than that of solute, less than that of solvent, the solution has to be heated more in order to equalize its vapor pressure to the atmospheric pressure. So since the vapor pressure of the solution is less, what you need to do is the solution has to be heated so that the vapor pressure becomes equal to the atmospheric pressure. Therefore, the boiling point of the solution is more than that of pure solvent. So the boiling point of the solution is more than that of pure solvent. Say for example, if you try to understand through this graph, the first graph, upper one is for solvent and the lower one is for solution. Now along x-axis we have plotted temperature and along y-axis we have plotted vapor pressure. So if you see at this temperature where the vapor pressure of the solvent becomes equal to the atmospheric pressure, that will be the boiling point of this solvent. And over here the temperature at which the solutions becomes equal to the vapor pressure of the atmospheric condition is the boiling point of the solution. Now from this graph we can see that the boiling point of the solution is higher than the boiling point of the pure solvent. Now this increase or this change in the boiling point of the solution, this increase or change in boiling point of the solution is known as elevation in boiling point. That means how much increase in boiling point has taken place. Therefore, the difference in the boiling point of a solution denoted by T is boiling point of the solution, and the pure solvent, that is denoted by T naught, is called elevation in boiling points. That means del TB, this is elevation in boiling point. Change in boiling or increase in boiling is given by boiling point of the solution minus boiling point of a pure solvent. Now, from experimental observation, it has been found that elevation in boiling point is directly proportional to the molality of solution, that is number of moles of solute per 1000 gram of solvent. This is the definition of molality of solution. So it has been experimentally formed. So we can just write elevation in boiling point is denoted by delta TB, directly proportional to small m. Small m is the representation for molality. So if you remove the proportional sign, we will put some constant. Let that constant be Kb over here. Now Kb means, Kb is a constant which is known by a name known as molar elevation constant, or we call ebullioscopic constant of the solvent. Now if you want to define this constant, so what you can do is, if you take the value for molality as 1 or 1 unity, okay, so at that time what will happen, then delta TB, that is elevation in boiling point, will be directly equal to the Kb, that is molar elevation constant or ebullioscopic constant. So from this we can define as, it is defined as the elevation in boiling point when molality of the solution is unity. That means when you take the molality of solution as 1, then that ebullioscopic constant will be equal to the elevation in boiling point, or when 1 mole of solute is dissolved in 1000 gram of solvent, that is 1 molal. Okay. Now once again from that expression, delta TB equals to Kb into m. This m is molality, and which is given by the formula number of moles of solute per 1 kg of solvent. So which is given by number of moles is given by weight in gram by molecular weight of the solute divided by, since there is 1 kg of solvent, if you take in gram, then it would be weight in gram divided by 1000. So when you just simplify it, it will become as 1000 into small w into m, small m, into capital W. So if you substitute this value for m in this equation, it will become like this. Okay. Now finally from this m, molecular mass of the solute, will be equal to Kb, that is molar elevation constant, into 1000 into small w, that is weight of solute, divided by delta Tv, that is elevation in boiling point, into weight of solvent in gram. So this is the final expression that we have derived from the elevation in boiling point. Now with this expression, in our last class we'll be doing the numericals. So you just go through all the steps, how we have derived these terms, how we have derived this expression, so that in next class we'll be using these equations, or we can say expression, for our numerical calculation.